it complementary because the last few videos that I made, I forgot to actually explain or how do we measure the time complexity of the solutions, because that is important, especially if you are uh, enjoying this video because you are preparing for interview. It's not that really important if you are enjoying this video to solve a puzzle, to understand it only. But if you are trying to prepare for interview, that's important because that is one of the big evaluations that they do, at least in several companies that I know, like Meta or Facebook and Amazon, where I work. So that's why it's pretty important. Why? Because time complexity is an indication of when you actually how efficient it is, how many times of efficient that you are working on. Okay, so I'll just remove this because we don't going to talk about it. What we are going to talk about is the efficiency. So one of the way to the time complexity of this. So this is the optimal solutions. As you can see, this is 94% faster than the other. Okay. So how do we measure? So basically, one of the easy way is actually to run it from top to bottom and try to see what is the value. First is we need to define. N is defined as the number of things inside the nums, because that's what is growing, right? The membership inside the nums. For this, the get sign, it will be big O1. We don't do any looping here, it's just comparison. This is also, we can treat it as big O1 because there is no loop and all here, right? There is no recursion, no loop. This is, yes, this is multiple line, but in terms of big O notation, this is just big O1, a constant. And then this is when it starts. This is definitely looping through each nums. So this is a big O(n), and then let's see the inside of it. This is just a comparison and append. So it's just one. So in total at this line, this for loop is just big O(n). Then this one, let's see. So the separation is created by here. Of course, we can have as many as n separations, correct? Because if everything is 0, or if it even if it is just half of it is 0, is n per 2. In big O notation, it's the same with big O(n). Okay. So this one is just a simple one. This is just another get marks. The get marks just now is just big O(1), right? There is no loop inside. And then this is another loop. So in this loop, it will be at least big O(n), because it could be that one single s will actually the n. But how do we combine it to the top? Remember that this is just the same number being separated out, right? So this is not n squared actually. This is still n, because n represents the total membership in the nums. And this 2 for loop, although this is 2 for loop, in total it's still n, because the logic here, how we create these two separations, is by separating the n. We don't duplicate the member, we just group it. All right, so that's the thing that we need to be careful when we measuring the big O notations here. It looks like 2 loops, and the worst case for each loop is the n, but actually when these 2 loops together, it's still just big O(n), not big O(n) squared. And then this is just multiplication, comparison, get sign is only a big O(1), the marks also only like that, only big O(1). So in total actually this section only costs us another big O(n). How about this? This is just comparison. So this is just big O(1). So in total there are 3 sections, and the 3 sections is n plus 1. So the time complexity for this one is big O n. Okay, so that's it for this one. This is the, oh yeah, what problem is this? Correct. That's a good question. This was the problem of 152, maximum product subarray. Okay, that's the thing I need to remember to mention before I'm explaining about stuff. Another one is about this one, the problem 2249, count lattice point inside a circle. How we measure the big O(n) of the solution. Later on, you actually can also visit the solution video for each of these in the descriptions below. I will put in all the links there to the video so you can relate to it. And also, of course, in reverse, I will also attach the link of this video to the other one. Next time, I will not forget to explain about the big O(n). Now, how about the big O(n) here? This is just illustration, of course, big O1, C in circles, so that will be, let's say we have 2 things, right? C is the number of circles. This is a list. Yeah, just n, because every circle just defined by 3, right? The x, y, and r in this problem. So we just need to have one definition of n, which is the length of the circle. In this case, this is big O(n). Instead of here, this is making a string big O1, checking into hash map is big O1. This one is initialization big O1, big O1, big O1, multiplication. Now this one. This is basically the xi minus ri, xi plus ri. So these are basically big O. We need to have the radius and the I. So this is actually as many as a radius could be, right? 2 times radius, basically. Same with this. This will be big O 2 times radius, because that depends on the radius. Then that will be it. This is just Pythagorean logic, no looping there. This is inserting into memo. This is checking in hash map. So this is just big O1. So 2R here, big O1 here. In this case, because I've really doing another 2R, so it's actually this. So it's actually 4R. Let's just do this here, so it's easier to understand. 4R squared, right? Now, let us look at what it means. It means that now we go back up. So this loop is inside this loop. So it means it's multiplications. Let's simplify this one first. It's become big O(r) squared. The total becomes nr squared. That is the complexity, the time complexity. Now, if we go up here, another way, actually, if we want to argue, the r at maximum can only be 100. So, in a sense, we can always say that this is actually 10,000 times n at worst case, because the r is limited by the constraint if we want to. Of course, this doesn't really make sense because the circle also have a limitation of 200. So let's just keep it at this, okay? So we need to know the n and the radius, and that will determine the time complexity, n times r squared. Remember how do we do that? Basically, we go to top to bottoms, and then from bottom we go back up. If you remember, I was starting from n here, big O R, and then I go back here, become r squared. I go back here, become n times r squared. Okay, so that's for this. Now let's go to the last one. Problem 2248, intersections of multiple arrays. To make a big O(n) here, same. This is just one, big O1. This is starting to be the loop. Let's say n is the length n, so this becomes big O(n). Here, for each nums I, there is another one. Oh yeah. So we need to know the m. Let's consider it as the m. Okay. The m is basically, let's say, the maximum values of the contents of each subarray. And then underneath this is just comparison, and this is just initiating value, so just pick O1. So at this level, we come back up, become n times m. Okay. Then here is already outside the loop. This is listing. You can treat this as a conversions. If it is conversion, maybe underneath it actually it's trying to run it one by one at worst case. And the number of result definitely is, the worst case will be n. Why not n times m? Because the problem is looking for member that is all inside each array. So definitely the maximum will be taking all members. It could not be n, which is m. So it could not be m times n. Okay? Because it is an intersection. Then this one is a sorting of something with the size of m. So this big m log m. So this is outside of the loop, right? So the total will be summation. At this top loop, it becomes n times m. This one is m. This one is m log m. So in total, in big O notation, you take the worst, which is n times m. Because m log m definitely, well, it's really, say, it really depends. Because, let's see, the length can be 1000, while nums ij also 1000. So it's because both can be 1000, so that is the functions of the constraint. This is the right answer. Because m log m definitely is smaller than mn times m. Right? Because why? Both have the same possibility of the highest numbers. So this is the answer. So remember, constraints is very, very important in a problem. And if you are doing interview, usually they don't, this is the things that is nice to ask. That shows that you are having a sense of details. Okay, so that's it for the big O notations for time complexity analysis. Hopefully that helpful.